Hi! In this video, we will discuss a little bit of dataset cleaning and see how to check if dataset is shuffled. It is important to understand that the competition data can be only a part of the data organizers have. The organizers could give us a fraction of objects they have or a fraction of features. And that is why we can have some issues with the data. For example, we can encounter a feature which takes the same value for every object in both train and test set. This could be due to the sampling procedure. For example, the feature is a year, and the organizers exported us only 1 year of data. So in the original data that organizers have, this feature is not constant, but in the competition data, it is constant. And obviously, it is not useful for the models and just occupies some memory. So we are better to remove such constant features. In this example dataset, feature F0 is constant. It can be the case that the feature is constant on the train set, but has different values on the test set. Again, it is better to remove such feature completely, since it is constant during training. In our data, such feature is F1. What is the problem actually? For example, a linear model can assign some weight to this feature, so this feature will be a part of the prediction formula. And this formula will be completely unreliable for the objects with the new values of that feature. For example, for the last row in our dataset. In general, even if a categorical feature is not constant on the train part, but there are values that are present only in the test set, we need to handle this situation properly. We need to decide, do these new values matter much or not? For example, we can simulate this situation with a validation set and compare the quality of the predictions on the objects with the seen feature values and objects with new feature values. Maybe we will decide to remove that feature, or maybe we will decide to create a separate model for the objects with a new feature values. Sometimes there are duplicated numerical features. That is, two columns are completely identical. In our example dataset, it is columns F2 and F3. Obviously, we should leave only one of those two features, since the other one will not give any new information to the model and will only slow down training. For numeric features, it's easy to check if two columns are the same. We just can compare them element-wise. We can also have duplicated categorical features. The problem is that the features can be identical, but their levels have different names. That is, it can be possible to rename levels of one of the features, and two columns will become identical. For example, features F4 and F5. If we rename levels of the feature F5, C to A to B, and B to C, the result will look exactly as feature F4. But how do we find such duplicated features? Fortunately, it's quite easy. It will take us only one more line of code to find them. We need to label in code all the categorical features first, and then compare them as if they were numeric. The most important part here is label encoding. We need to do it right. We need to encode the features from top to bottom, so that the first unique value we see gets labeled 1, the second gets 2, and so on. For example, for feature F4, we will encode A with 1, B with 2, and C with 3. Now, feature F5, we will encode it differently. C will be 1, A will be 2, and B will be 3. But after such encodings, columns F4 and F5 turn out to be identical, and we can remove one of them. Another important thing to check is if there are any duplicated rows in the train and test. If there are a lot of duplicated rows that also have different target, it can be a sign that the competition will be more like a roulette and our validation will be different to public leaderboard score, and private standing will be rather random. Another possibility, duplicated rows can just be a result of mistake. There was a competition where one row was repeated 100,000 times in the training dataset. I'm not sure if it was intentional or not, but it was necessary to remove those duplicated rows to have a high score on the test set. Anyway, it's better to explain it to ourselves. Why do we observe such duplicated rows? This is a part of data understanding, in fact. We should also check if train and test have common rows. Sometimes it can tell us something about dataset generation process. And again, we should probably think what could be the reason for those duplicates. Another thing we can do, we can set labels manually for the test rows that are present in the train set. Finally, it is very useful to check that the dataset is shuffled, because if it is not, then there is a high chance to find a data leakage. We will have a special topic about data leakages later, but for now we will just discuss how to check that the data is shuffled. What we can do, we can plot a feature or target vector versus row index. We can optionally smooth the values using running average. On this slide, rolling target value from Quora question pairs competition is plotted, while mean target value is shown with dashed blue line. If the data was shuffled properly, we would expect some kind of oscillation of the target values around the mean target value. But in this case, it looks like the end of the train set is much different to the start, and we have some patterns. Maybe the information from this particular plot will not advance our model, but once again, we should find an explanation for all extraordinary things we observe. Maybe eventually we will find something that will lead us to the first place. Finally, I want to encourage you one more time to visualize every possible thing in a dataset. Visualizations will lead you to magic features. So this is the last slide for this lesson. Hope you've learned something new and excited about it. Here is a whole list of topics we've discussed. You can pause the video and try to remember what we were talking about and where. See you later.